All right, today we are going to continue with proving triangles congruent and introduce proofs. So let's get started with some of the examples already color coded for you. So for this first one, you have to use the given postulate or theorem, indicate which parts you would need to show that it's congruent. So we're looking for it, which one would you need? So let's look at number one. We need side, angle, side. So let's look at what is provided and what we need. So it provides the sides. It provides an angle. So in order for this, we need a side. So it would have to be side, angle, side. So the side we would need to make this congruent would be AE, which is congruent to BD. And those are both highlighted blue. So for number two, again, you are looking for what is going to make angle, side, angle. So let's look at what's provided. We have an angle in pink. We have a side that's given. Notice that's showing you that the side is given. Those are congruent. And we need this last angle. Well, if it's angle, side, we need the angle right next to it. So angle, side, and you need that angle to make it congruent. So angle A is congruent to angle E. All right, on this one, you need three sides to make it congruent. So let's look at what's provided. So what is provided is BC, and right here, CD. And also they both share this side, so it's congruent to itself. That's called the reflexive property. You'll learn about that in a second. So we've got a side, we've got a side, so we need this side here to make it congruent. So again, we were given a side, it shares a side with the other, so it's congruent to itself, and we need this side to make it congruent. So AB is congruent to AD. All right, you're going to try these. So go ahead, try those using these theorems and postulates. So this needs to be angle, angle, side. This one should be hypotenuse, leg, and angle, side, angle. So go ahead, try those. Next up, we're going to use the information in the diagram, state the information that's already given. So in this case, it's given because it is marked that EC is congruent to EA, and you know that because it's already marked. And then it's also provided that angle C, and I did go over it a little, but you can see that it's marked. So angle C and angle A are congruent because they're both right angles, and that is provided. So now that we know that EC, so that's a side, that's an angle, we need to think what other information is given, or not given, excuse me, what other information can we get from this by looking? Well, we can get here, those are vertical angles. So based off of this is congruent to that angle. So angle CED is congruent to angle AEB. And that's shown here on your diagram because of vertical angles. So now, we said before, we were given an angle, we were given a side, and then we have another angle. So this would be angle, side, angle. So you can prove that they're congruent by using angle, side, angle. All right, next up is what I call, or what is called the reflexive property. And it's a property that names something that is seemingly self-evident. So if it's seemingly self-evident, I like to go, it's the duh. It's almost too easy because it's obvious of what it is. So it can be any line, segment, angle, or shape is congruent with itself. Well, if it's congruent with itself, that means it's the same thing. So reflexive properties allow us to write the following congruent statements. So if you look here, you have segment AB. Well, AB is congruent to AB because it's congruent with itself. So it's seemingly self-evident, which makes it the reflexive property. Now here you have angle C. So angle C is going to be congruent to angle C, which makes sense because it's the same angle. So again, these are the seemingly self-evident ones. These are the ones that are like, well, yes, of course it's congruent to itself, but this is the reason for it, is a reflexive property. So let's go ahead and let's complete this. It says state all the information given in the diagram. Well, I highlighted it for you. So LO is congruent to VO, and if you notice, they both show they're congruent there, so that's what I wrote here. And then it says that LE is congruent to VE, and you know that because they're both marked there. So that's what's given in the diagram. Now, information that can be concluded is if you look here, OE is for both triangles. So that's one triangle. And that's the other triangle. So OE is used for both triangles. So it's actually congruent to OE, and that's because of the reflexive property. So it's congruent with itself because this side is shared here and it's shared here. So it's congruent to itself. So therefore, now let's look at all the information that's given. I've got a side, I've got another side, and I've got a third side. So yes, we can prove this is congruent because of side, 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 and that's all you got to do for that one. All right, now we're going to start what's called a proof. A proof are just the steps that show how to prove whatever it's asking for. In this case, we're proving that this triangle is congruent to that triangle. So the first step you always want to do is write whatever is given. So this is going to go right here. Your first step is always going to be what's given information. So it could either be written there or it could be provided on the picture. So the next step is it tells us that angle GFH is congruent to IFH. So that's what I did in green. And we know these are congruent because this bisects, FH bisects this. So if it bisects it, this is congruent to that. And that's this one right here. All right, so then the next step we have to prove that one triangle is congruent to the other is FH. Well, it's a bisector, but it also, this is congruent to this. And if you notice, they both share this line right here. So we're saying FH is congruent to FH, which is your reflexive property, meaning it's congruent to itself. And then finally, we're going to take all that information and we're going to say triangle GFH is congruent to triangle IFH because of angle, angle, side. So again, angle, angle, side. Angle, angle, side. And that's what will prove those are congruent. All right. So on the next one, these you've got to fill in a little bit. So the first step is either what's provided in the picture or what we'll do here. So remember, given is always going to be the first thing you're going to write, whatever is given. So here it says BC is congruent to DC. So BC is congruent to DC, and if you notice, I already marked it like that. And then you have AC is congruent to EC, and I marked it here. So that's the information that's provided. And then now the next step is that, oops, angle BCA and DCE are vertical angles. So if they're vertical angles, then that means it's just the definition of vertical angles. And if you notice here, make it a little bit thicker. Right? So that is the definition angles. So you can say this is true because that's the definition of the vertical angles. All right, the next step to prove that these two triangles are congruent is we're going to use a vertical angle theorem, and we're going to list what the actual vertical angles are. So it's going to be angle BCA is congruent to angle DCE. So BCA, so this is one angle, and then DCE, that's the other angle. So remember, those are the angles, that's your vertex there. And we know that these two are congruent because of your vertical angle theorem. All right, last but not least, we want to know, how is triangle BCA congruent to DCE? Well, we know this now because we have a side, we have an angle, and we have another side. So we have a side, we have an angle, and another side. So since it's a side, an angle, and a side, that's how we can prove that this triangle is congruent to that triangle. And that is how you do proofs. You've got your reflexive property where it's congruent to itself, and then practicing and proving how triangles are congruent.